So 22, 1973, right? Oh, don't do this full screen thing again. For some reason, I can jump it into full screen, and I have no idea why it does it, but it's okay. This one right here, 22. Ooh, is it a particle one? Particles are like my favorite. Yeah, hold on. Let me. Don't give away the story. Let me do the punchline here, Stephen. 22. Okay. So on 22, we have particle motion. You should love particle motion questions. Or you should. I don't know if you do, but you should. You'll try? Okay, you'll try for me. Good. A particle moves along a curve so that the x component has velocity that at time 0 and the particle component at time 1, the particle's at what point? Okay, so in order to get where the point is, what function are we going to need to figure out?
X of t and y of t.
Excellent. So we have y equals ln x so that the x component is, oh, okay, so there's x prime of t. So what should we do at this point? What do you think we should do? Find the integral of that, right? So we can find the x position, right? So what is x of t going to actually be? 1/2 t squared plus t plus what? C. And it tells you that at time, at t equals 0, what point is it at? 1, 0. So if we plug in x of 0, right, we get 1/2 0 squared plus 0 plus c has to equal what?
1.
So what does c equal? 1. So what does x of t equal? 1/2 t squared plus t plus 1. So we have x of t. That's kind of nice. So what do we have to find now? When t is 1, what's the x coordinate? So if we do x of 1, what's that going to be? 1/2 1 squared plus 1 is what? 5/2. So we know where the x coordinate is. Oh wait, how do you find out what the y coordinate is? Yeah, we know y is equal to what? ln x. So therefore, y when x is 5/2 is ln of 5/2? 5/2. 5 over x, and x is 5/2. So ln of 5/2. Is that one of the answers? Excellent. Fantastic. No, but keep in mind, this is really important. We've talked about this a bunch of times. Just because the eventual path that we find is relatively short and straightforward does not mean finding it is. There's a lot of different directions. Like there's a mean value question on. I mentioned this before. Like there's a mean value question on this one, which was like, let's go in this direction, and then this direction, and then this direction, and then you get all these answers that you think are right because they're listed, and then they're not, and then you're sad, and then you finally find it, and you're like, oh, this is actually hard. Okay. You need to remember what the arc length formula is for y equals f of x, right? And that is a to b of what? 1 plus what? Yeah, 1 plus f prime of x squared dx. And in this case, you need to remember what y prime is. That's going to be 1 over secant x times the derivative of secant, which is what? Secant x tangent x. So that cancels, and you're left with y prime is equal to what? Tangent x. So you're plugging this in, and you're going from what to what? 0 to b? 0 to, I think it's just 0 to b, right? So it's 1 plus tangent squared x, which makes you feel nice because you remember that 1 plus tangent squared x is what? What is it? Now, how do you remember these? I honestly don't remember the other Pythagorean trig identities. I remember this. Sine squared plus cosine squared is equal to what? 1. Divide by sine squared, and what do you get? 1 plus cosine squared over sine squared is equal to 1 over sine squared. So that's 1 plus cotangent squared is equal to cosecant squared. Divide by cosine squared, and what do you get? Sine squared over cosine squared plus 1 is equal to 1 over cosine squared. So what would that be? Tangent squared plus 1 is equal to secant squared. So what does this mean? You have 0 to b of the square root of secant squared x dx. So you get 0 to b of secant x dx. And is that one of them? It is. You must remember your trig.
I know the
You gotta remember your trig. So kids, I'm not kidding. This is what I remember. This is all I remember. Because I totally know if I try to remember these final ones, I'm going to mix them up.
Yeah.
I just remember this and divide. It takes 2 seconds, and then I have it right there. Remember the division. Call it the Eric Krieger method of doing things. Okay, so the challenge here is they're telling you what to substitute, right? They're actually telling you what to substitute. The challenge is that you can make that first substitution. So you're like, oh, I'm going to make it sine y over what? The square root of 1 minus x dx. But they're all in terms of what? They're all in terms of dy. So we have to substitute out. The challenge here is you have the square root of x equals sine y. First pro tip, do not start squaring things. When you start squaring things, you have to be really, really careful to take care of any added untruths that you fold into the mathematics. Squaring things can make untrue things true. Does negative 5 equal 5?
Sometimes.
Does negative 5 equal 5? It does not. But if you square both sides, do you get the same thing? Yes. You have to be very careful. In this case, if you wanted to isolate y, right here, what does y equal? Sine inverse of root x. So if you want dy dx, what's the derivative of sine inverse? 1 over the square root of 1 minus root x squared times the derivative of the square root of x. What's the derivative of square root of x? It's 1 over 2 root x. It's 1/2 x to the negative 2, negative half. Are you with me so far? What can we isolate now? We have dy dx. What can you isolate?
dy.
We can dx. What's dx going to be? Dx is just going to be 2 root x root 1 minus x dy. Where can you plug this in now? Where can you plug that in? Right here. And what do you end up with? Sine of y over the square root of 1 minus x. That's not 11. It's just 1. Times this. 2 root x root 1 minus x dy. What cancels? Root 1 minus x. And what can you factor out? 2 sine y. But what is root x? What is root x? Look at the top. Sine y dy. So you have 2 integral sine squared y dy. What have I not written in? The limits of integration. What were the original limits of integration? So right here, what do we know y is equal to? Sine inverse, right?
Yeah.
What's the lower limit? So what's y is equal? What's sine inverse of 0? The sine of what is 0? 0. And the sine of what is 1 over, why did I put 1 over root 2, by the way? Because it's the square root of 1/2, right? Look, the function is y equals, the function is, this is a square root right here. So if you plug in a half, what do you get? 1 over root 2. What is the sine of what is 1 over root 2? Pi over 4. So do we now have our limits of integration? Yeah, we do. 0 to what? Pi over 4. And is that one of the answers? It sure is. Let's say you didn't isolate y. You could differentiate this, but you need to differentiate it with respect to, like, let's say t. Okay? If you wanted to differentiate this with respect to t, what would you get? You get, tell me what you get if you differentiate this with respect to t.
1 over 2 square root x.
Yeah, 1 over 2 root x, 1 over 2 root x dx dt equals cosine y dy dt, right? Multiply both sides by dt, and what do you get? Dx over 2 root x is equal to cosine y dy. You see that right there? Are you with me so far?
On a read.
So what you can do now is, what can you isolate now? What does dx equal? What does dx equal? Tell me.
Cosine y dy
2 root x cosine y dy. You with me so far? You can then use that if you wanted to back in your original. The challenge is this. The challenge is that you will have to do some creative algebra to do some canceling to get rid of that cosine. It does work. You have to be very careful with it though. This, what I showed you, is my vastly preferred method. Right here. But what does it rely on, everybody? What do you think the most common showstopper is? Oh, this right here. You have to have that as an automatic. It has to be an automatic. Thing, right. You did that, and did it not work for you?
I get confused.
You get confused? You know, I don't think you get confused.
I get X like that.
All your pastel handwriting is what makes you confused, okay?
No, I'm wearing in black, so.
You couldn't even read it. You would-
Yeah, I still can't read it,
It took
okay?
me 4 years to get him to switch to black. Like, teachers have been telling me for years since middle school.
I've written in your comment, like, Perfect.
I saw
Please
that.
write larger, please. Okay, so am I allowed to do that? Can I take the ln of both sides?
Yeah.
Yeah.
Now what type of differentiation do I do? Implicit, thank you very much. But what do I do? What can I bring down first before I do implicit, actually? So you have ln y is equal to ln x times what? So what's that the same as? Yes, you can say ln x squared. So then you have 1 over y prime is equal to 2 ln x times what? Times 1 over x. So what does y prime equal? Y prime is equal to y times 2 ln x over what? X. But what does y equal? X ln x. So what do you have here? Y prime is equal to x ln x times 2 ln x over x. Is that actually one of them? I think it's this right D right here. Right? Oh, there's a 2. Susie, there's a 2. Thank you. There it is. Yay, exciting. Super fun, yay. Lead me through it. What do you okay, anybody have an idea? What do you do? I said give me any idea you want. You're saying, Fiona, I think this is what you're saying. You're saying that this right here is equal to the integral from 1 to 2 of what? X over x squared dx minus 4 times 1 over what? Dx. So what does that equal to? That's the integral from 1 to 2 of 1 over x dx minus 4 times the integral from, it's the same thing, right? I don't see why this doesn't work. What's the integral there? So this is going to be ln of x from what? 1 to 2 minus 4, and that's x squared, not x, I don't know what that is. 4 times what? Integrate it for me.
Negative x to the negative.
It's negative 1/3 x to the,
What? No, negative.
I can't,
X to the -1.
negative x to the -1 like this,
Yeah.
from 1 to 2. I think this works, right? So this is ln 2 minus ln 1, right? Minus 4 times, you have to be real careful on this, right? What is this, negative 1 over 2 minus,
Plus.
plus? Why plus?
It's minus
Oh, minus a negative, so, oh, okay, you're just doing the minus the negative, plus 1 like this? So what do you get, ln 2
plus
plus
2.
2? Well, times minus 4, it's going to be minus, it's going to be a half, so it's going to be minus 2. Is it like this?
Yeah, it's minus
Negative.
No, it's because it's going to be, that together is 1/2, right?
Oh, yeah.
Correct? ln 2 minus 2, is that one of the answers? Oh, look at that. Nice. I love the breaking apart thing. That's great. Fantastic. I'm sure there are other paths. I'm sure there are other paths. That's not bad, though. Does that match the answer in the book?
Yeah.
Thank you. What did you say u is equal, what did you set u equal to, Brenna? What? Sine inverse of x? So therefore, what's u prime? Dx. So that makes, what does that make v prime? Dx, or 1, yep. So v is equal to x. So by parts is the integral of what? What's the formula? uv prime dx is equal to what? Minus the integral of u prime dx, right? So if we do that out, we end up with u times v, so we end up with x sine inverse of x minus the inverse of 1 over the square root of 1 minus x squared dx times v, which is x. So what does that match? Which one does that match? E. So if you remember your inverse sine, you are good to go. If you remember it, you are good to go. Okay, so now